Welcome to SUSECON Digital 2022. This session is titled Releasing Kubernetes. Kubernetes is an open source container orchestrator, which has been productized by many organizations and has become a business critical platform for many. For today's agenda, we will first review how enhancements and code changes for those enhancements make into release. But before we do that, we need to review who owns the code. So first, we're going to talk about the Kubernetes special interest groups. Then we'll talk about the Kubernetes enhancements proposals and talk about the enhancement process. Then we'll review the release cycle and we'll tie it back the Kubernetes enhancement proposals on how they're used in the release cycle. Then we'll go into release day activities and review how we cut a release. I'm your speaker for this session. My name is Rey Lejano. I am a field engineer with SUSE by way of Rancher Labs. I'm also an upstream Kubernetes contributor. I was the Kubernetes version 1.23 release lead. I am the Kubernetes version 1.25 Emeritus Adviser. I am the co-chair for the special interest groups for documentation. I'm also a sub-project lead for the special interest group for security. So speaking of special interest groups, we will first need to discuss how the Kubernetes project is run, distributed, and who owns the code. So before moving on, from now on, I'm going to refer to special interest groups as SIGs, and Kubernetes is composed of 24 SIGs. Each SIG is comprised of many members from multiple companies and organizations, all with a common purpose of advancing the Kubernetes project with respect to a specific topic. Each SIG focuses on a part of Kubernetes. Each SIG, they might own code. Some might own documentation. Some might, and they each have their own policies as well. The goal for these SIGs is to enable a distributed decision structure and to distribute code ownership. Each SIG is like a focus form for getting work done and to make decisions and to onboard new contributors. Actually, every identifiable part or subpart of the Kubernetes project, it could be every subdirectory, every API, every test, every issue, every pull request is actually owned by some specific SIG. Well, there's three basic types of SIGs. First off, it's the horizontal SIGs, which span multiple functional areas like security, scalability, architecture. We'll go into greater detail of all these SIGs in the next slide. Then there's the vertical SIGs, which are focused on a specific component area, like SIG network, storage, scheduling, CLI. And there's project level SIGs, which supports the entire project, like testing, release, documentation, contributor experience. SIGs, they do have their own sub-projects within their SIG as well. These are smaller groups with a very specific focus on and they also own code, and they might own their own documentation as well. Example of sub-projects is like the kubelet sub-project under SIG node, also the kube control sub-project under SIG CLI. SIGs ideally have two co-chairs. Some might have more, some might have just only one chair. But ideally, they would have more than one chair. And each SIG has their own charter, and they run their own meetings on a specific cadence. SIGs do intend to collaborate with each other as well. So going over the different 24 SIGs of Kubernetes, starting off with the project level SIGs, which I mentioned which supports the entire project, starting off with SIG architecture or SIG arc, which maintains the design principles of Kubernetes and makes sure that there's architectural consistency. So they govern the API definitions, API conventions, API review process, conformance testing, conformance test definitions as well. Review and management of those conformance tests, the deprecation policy as well, and the upgrade and downgrade policies as well. Next is contributor experience, or also referred to as ContribX. This SIG helps to improve the upstream contributors' experience in the Kubernetes project. So they manage like the GitHub management, the mailing list, Slack, YouTube, mentoring programs like Google Summer of Code or Outreachy. And then there's SIG docs or documentation, which helps publish the Kubernetes and maintains the Kubernetes documentation on kubernetes.io. They are also responsible for the reference docs for the API, kube control, and kubeadm as well. And then there is SIG release as well. SIG release is responsible uh, to make sure that we produce Kubernetes releases on a reliable schedule. They also manage the different code branches of the Kubernetes/Kubernetes repository. They produce the binary artifacts like the Debian and RPM packages, the container images as well. And they also define and drive the development process as well. Like, do we do fast forwards or do we do cherry picks, and do we approve those cherry picks as well? Next is SIG testing. SIG testing is governs the testing of Kubernetes and also helps to automate away any project toil. So they help create and run tools and the infrastructure that makes it easier for the community to run tests and contribute and analyze those test results as well. SIG usability is responsible for the end user usability of the project. So they cover like user experience and accessibility as well. Excuse me. SIG hates infra. So just a little background that the current um, so most of the Kubernetes, I guess, infra that's used, it's actually owned by Google, and so it's on like GCP. SIG Infra is in charge of the migration of the Kubernetes project from Google-owned infrastructure to CNCF-owned infrastructure. Next, we have the horizontal SIGs like API machinery, which is responsible for to develop and enhance the control plane aspect of Kubernetes. So this includes like the API server, of course, etcd, controller manager, cloud controller manager, webhooks, etc. Excuse me. Then there's SIGAuth, which is responsible for the design and implementation and the maintenance of how to control and protect access to the API and other core components. So they govern things like authentication and authorization. So they also govern features like auditing and some security policies as well. So they also make sure that we're able to encrypt and that we have encryption at rest, that there's secure communication between components as well. SIG CLI is responsible for kube control and other related tools like Kustomize. SIG instrumentation owns the best practice for observability through like metrics, logging, events, tracing across all the Kubernetes components. So they manage things like Klog and kubestate metrics. There's SIG multi-cluster, which helps solve the issues and challenges of managing multiple Kubernetes clusters. SIG scalability, which drives the scalability goals for the project. SIG security, which is a horizontal security initiative for the Kubernetes project. So they run regular third-party security audits. They manage the vulnerability management process. They make sure that there is documentation on how to secure your clusters or like RBAC good practices guide, etc. There's SIG UI, which is the Kubernetes dashboard itself. Windows or SIG Windows maintain or governs the operation of Kubernetes on the Windows operating system. Then we have the vertical SIGs. We have SIG apps, which covers the developing, deploying, and operating of applications on Kubernetes with the focus on the app developer and also the application operator. SIG auto scaling, which manages and governs the components for automated scaling in Kubernetes, like the horizontal pod autoscaler and the vertical pod autoscaler, and also the autoscaling of clusters. There's also SIG network, which is responsible for the components, the interfaces, and the APIs, which exposes the network capabilities, which is responsible for the components that for the interaction between pods and the host resources. So SIG node, one of the subprojects, is like the kubelet. Also, the node controller, node API itself, the interface with the container runtimes, device management, hardware discovery, etc. There's SIG scheduling, which is responsible for the components that make those pod placement decisions or scheduling. So it manages all the scheduling components. There's SIG storage, which is responsible for the components or to make sure that those containers of the pod has access to the different types of file and block storage. So they govern things like the persistent volumes, persistent volume claims, storage classes. Say cloud provider maintains the cloud provider integrations like as extensions or add-ons. And then finally, SIG cluster lifecycle helps to simplify on how to create and how to configure and how to upgrade Kubernetes clusters. So they manage when they have subgroups or subprojects for like kubeadm, kops, cluster API, kubespray, minikube, etc. So those are your 24 SIGs that compose the Kubernetes projects. Next, we'll talk about the Kubernetes enhancements proposals, and I'll refer to these as KEPs from here on forward. And KEPs, excuse me, next few slides, we'll talk about how KEPs are in the Kubernetes software development lifecycle. And KEPs are used to propose and communicate changes to the subprojects or to the projects of the different SIGs. And the KEP process has been mandatory for all enhancements or features since Kubernetes 1.14. So KEPs, many processes from KEPs was actually borrowed from the Python enhancement proposal. Excuse me. And KEPs is a way to standardize the development process for Kubernetes. So we have a common structure on the proposed changes to the Kubernetes project, and in that we make sure that there's a clear motivation for the enhancement or feature. Ensures there is criteria for the enhancement or feature to go through the graduation phases, like to alpha, introduces alpha, graduate to beta, graduate to GA. And this unit of work is called a KEP, and it has a few things. One, it has a KEP README, which we'll review in the next few slides here, which makes sure that it tells you and describes what the motivation of the KEP, what the summary of the KEP, and has the testing plans of the KEP. Describes also the production readiness review of the KEP as well. It's meant to be a feature and effort tracking document, and also the product requirements document and the design document as well. What needs a KEP, or what is considered an enhancement, is any work that will be going through the graduation stages, like going introduced as alpha, graduating to beta, beta to GA, or any changes in the project that has any significant changes like to API, or changes that that impacts the operation or user experience, is considered an enhancement and will need a KEP. Every KEP is owned by a SIG, and some enhancements or some KEPs can actually have multiple SIGs that might have co-owning SIG, but there's always a primary SIG that owns the KEP. What is not enhancements, or what do not, or what are things that do not need KEPs, or like things like CRDs, custom resource definitions, do not need KEPs. Any performance improvements, same as bug fixes as well, they don't need a KEP. Code refactoring as well. In order to create a KEP, you first need to communicate with the SIG on your idea. You would probably join a SIG meeting or communicate async in the SIG Slack channel. You might create a prototype of your enhancement or feature to demonstrate in the SIG's meetings. Once the KEP is actually merged, then you could actually assemble contributors to work on the enhancements. And once the KEP is merged, then you could actually merge in code for that KEP. Then you could opt in for a release. And so then usually done by the SIG co-chairs or the SIG leads that can opt in enhancements for a release. So let's go and talk about the release cycle. Kubernetes releases 3 times a year for a minor release, which is every 4 months. And there's monthly patch releases as well. But the release cycle is primarily about these minor releases. Every 4 months, there are about 15 weeks per release cycle, and with 2 weeks of a break between the release cycles. There is the last release cycle of the year tends to have 16 weeks to accommodate for KubeCon North America and also some holidays as well. So the release cycle itself, it's actually managed by a release team, and it's made, which is part of SIG release. And the release team is responsible for the day-to-day work and operations to successfully release. This release team is made of about 35 to 40 community members. and there's 9 roles in the release team, which and some of the roles have shadows or apprentices. There is a shadow program for the release team, which is great for any new contributors to the Kubernetes project, or actually or veteran contributors as well to the Kubernetes project to learn about how the project releases. The release team itself has the authority to build and publish releases on a published release date with the CNCF, and also has the authority to accept or reject cherry picks as well to their release branch, and also accept the release team can also accept or reject pull requests during code freeze when if they want to make any accept any exceptions itself. Um, there's 9 roles, so I'll review some of them here, and we'll review some more in a few slides down. First, I'll start off with the release lead itself. The release lead is a person who has been a member of several release teams, usually, and at least usually has been a role lead at some time. They are responsible for coordinating the release activities and assembling the entire release team, and they have the ultimate accountability for all the release tasks to be completed on time. Then we have the Emeritus Adviser, who is the advisor on the team, and ideally, the Emeritus Adviser usually has been a release lead before. The Emeritus Adviser also helps to onboard new contributors or new shadows to the release team as well, and make sure that that the release team has a healthy and is growing part of SIG release. There's also the branch manager, which the branch manager is always a part of the release engineering team for Kubernetes, which is also a different subproject under SIG release. SIG release has 2 subprojects, one being release engineering, the other one being the release team. So branch manager is a release manager or release engineering, and is responsible for maintaining the release branches, tagging releases, building and packaging the Kubernetes project, Kubernetes itself. Then we'll talk about the other roles in the next few slides here. Let's talk about the release cycle first. Like I mentioned before, we do, excuse me, the Kubernetes project releases 3 times a year, and in about a 15-week cycle, and there's 2 weeks between cycles. At the very start of the release cycle, we assemble a release team. So it starts off in actually midway through or partway through the previous release cycle, where role leads are nominated to be the role leads of the release team, and same with the release lead as well. Usually, the first alpha release is usually cut when the previous release has been cut. So once the previous release has been cut, the first alpha release is actually created as well. The very first part of the release cycle, the first about 3 weeks or 4 weeks, is the enhancements collection, where we gather enhancements, or SIG leads and SIG co-chairs opt in for enhancements that want to be part of this specific release. Part of this process is also a production readiness review. So any enhancement that will be targeted or accepted into release will have to have an approved production readiness review that is governed by a small team that makes sure that the enhancement is ready and can be run in production. Next milestone is enhancements freeze. And during enhancements freeze, all enhancements wishing to be a part of this release must have a cap at a proper state, meaning that has included test plans, it has included graduation criteria, and it also has the proper release milestone as well. So we have a little break in between the work that's being done for the enhancement. So we have about 8 weeks or so where the work is being done for the enhancements. Then we approach, and during that time, the release team itself, they do various things like documentation. They are tracking which enhancements are collected and will be part of the release. So they take a look to see which enhancements needs updated documents or update documentation on Kubernetes.io, like if there's any feature gates, if there's anything that's going to be deprecated or removed, and has to be noted on the website as well. So then after about 8 weeks, in week 12, we reach code freeze. So meaning that All enhancements that are going into the release must be code complete, including all the tests as well. And also must have related documentation. Pull requests have to be open for those updated graduating enhancements or new enhancements as well. At this time, only at code freeze, only pull requests that fix release blocking issues will be allowed to be merged. The next key milestone is test freeze, and at test freeze, this is the date where there's no other tests can be updated or merged unless there are any release blocking things that require any exceptions. At this time as well is when we do the branch cut shortly after test freeze. Shortly after code freeze is actually when we do the one or two beta releases as well. Then we do a branch cut once we reach a test freeze. At this time as well, as the work is continuing with the enhancements, the various teams will do some work as well. We'll talk about that in the next few slides, like the release notes. They'll gather the major themes for this enhancement. The CI team or CI signal team will make sure that the CI signals are good before each cut, before each alpha cut, before each beta cut, before each release candidate cut. And if not, they will triage any failures in CI as well. So in about week 13, we have test freeze, and then, like I mentioned, we have the branch cut. So we have a release cut to work with now. Um, in part of 1.25 is the release we're starting to do branch fast forwards instead of requiring to do cherry picks from the master Kubernetes repository into the release branch. Then after test freeze, then we will release one or two release candidates as well. Then after in about 2 weeks or so, we have the final release. And after the release is cut, we have code thaw, which opens up the Kubernetes repository for pull requests to merge. After the release is cut, we have a set of feature blogs that highlight specific enhancements that are in the release. It could be like key enhancements are going to beta or to stable or GA, or it could be key deprecations or key removals as well. And there's also a feature release blog as well that highlights and summarizes the entire release. So kind of tying it back with the Kubernetes enhancement proposal that we talked about a few sections ago, the Kubernetes enhancement proposal is used by the enhancements team. So the enhancements team gathers and collects the enhancements or features that are going to be part of the release, and they use the Kubernetes enhancement proposal to track the progress of the enhancement or of the KEP as it graduates or as it's introduced as alpha, graduates to beta, graduates to GA. The same tracking issue will be used for the entire life cycle of the KEP or the enhancement. So it will be used by multiple release teams and also contributors as well to make sure that the enhancement is code complete for any state of that feature for that release. Also, make sure as well if there's any documentation that is needed for the enhancement, that tracking issue for that Kubernetes enhancement proposal will be used. At this time as well, the enhancements team to make sure that the KEP has the approved goals, motivations, user stories, make sure it has the graduation criteria, it has proper test plans, and also has an approved production readiness review. And once the KEP is merged or has been updated with that is targeting that release, then code for this enhancement or for this KEP can actually be merged. This is an example of a KEP README and a KEP.yaml. These are just sections of the KEP README. It just highlights that there's a summary. This is for generic ephemeral inline volumes. There's a summary. There's user stories and the motivations. It states the goals, but what's also important states the non-goals as well. The proposal and the design details of the enhancement and the testing and the graduation criteria, and also the production readiness review, which has been mandatory since last year for it to have an approved production readiness review. Each KEP as well also have a KEP.yaml, which is metadata that can be used or can be scraped as well to see what the status or the state of the enhancement is. So we could see with the latest milestone what that cap what has been worked on. Um, if it's stable, the versions to where it was stable, beta are introduced as alpha, who the production readiness reviewer is as well, and who were the reviewers for this enhancement proposal as well, and also any other feature gates that this enhancement might have under which components, and also the metrics of that is available for this enhancement. So that was the enhancements team that uses that Kubernetes enhancement proposal. Next, we'll just talk about the CI Signal team. CI Signal, they assume the excuse me, the CI Signal team makes sure that there's a high quality for the release, so they continually monitor all the end-to-end tests as well in various CI dashboards that we have for this release. The CI Signal team also hunts flakes on pre-submit that might block the Kubernetes master brancher in the future. They also monitor all jobs in various CI dashboards as well, and they provide the early and ongoing signals to the release team for the health of of their release and to various SIGs as well. They also triage any issues or any CI failures to the appropriate SIG to get those fixed as well. And they also study the patterns and history of the test. And they might also demote some tests if they deem that a test is like not blocking or it's not really a blocking test, that they can suggest for that test to be removed or demoted. They also work on the tooling to automate weekly reports to contributors as well. Some other teams that I just want to briefly mention for the release team is like bug triage, which they are responsible to make sure that all issues and pull requests, which are targeted to fix bugs for a specific release, are triaged and dealt with in a timely fashion. They also track and report any potential release blocking issues as well. Documentation or docs coordinates the documentation updates for the graduated or new introduced enhancements or any deprecations or removals. They also generate the API kube ADM kube control reference docs as well. Comms or communications, they are responsible for the communication between the release team and various other stakeholders like the CNCF, various media outlets as well, also various project managers that rely on the Kubernetes project as well. They also curate the official release blog, and they also curate a series of feature blocks that highlights in various enhancements of the release. Finally, release notes. They not only generate the release notes as for the release, but they also work on the tool to scrape GitHub pull requests to create the release notes as well. So that brings us to, after about 15 weeks, the release day activities and cutting a release. So the release team and release engineering, they use various tools. The main tool is CREL or Kubernetes release, and it is a release toolbox with several commands like announce or CREL announce that builds and announces the Kubernetes release. CREL changelog, which automates the lifecycle of the changelog. CVE or CREL CVE, which adds and edits CVE information. CREL FF or fast forward, which fast forwards a release branch. CREL release, which pushes the Kubernetes release artifacts to Google Cloud Storage. CREL release notes, which is the subcommand that's actually used by the release notes team. CREL stage, which is stages the new Kubernetes version. There's kpromo, which promotes the artifacts. Qpackage, which creates the Debian and RPM packages. BOM, which generates the bill of materials. So there's various release artifacts when a new release is cut, and these release artifacts are published to the Kubernetes GCS bucket, and then it's promoted into production. So various artifacts are like container images, binaries, tar archives, RPM packages, Debian packages. So on the actual release day, we do follow a process to cut the official release. There's two main stages. One is a stage, and one is the actual release. The stage builds the images and pushes them to GCS as well as GCR. Then we manually, excuse me, promote them during the while in the release phase. We also validate the images as well. So starting off, we do the first thing at first is we create a tracking issue in the Kubernetes slash SIG release repository. We use this tracking issue just to track the process of the release day activities. Next up, we take a screenshot of test grid to make sure that that the CI signal is good, that there's no failing end-to-end tests in CI, to make sure that we have a good release to cut. Next, we do a mock run. So here we're using the dash dash no mock flag. So it's a little bit different. So we run a command, either curl stage or curl release. So we would run this command and it would go through a mock run, pretty much a dry run, before letting the actual command make any actual impact on the release process. So we're doing it pretty much a dry run here. So we could verify that we have a working setup here. Next, we have the no mock run. So we actually use a flag for the crawl stage, crawl release command, the dash dash no mock flag. So now we're actually doing the no mock run. So we're actually doing the actual run to create the release, create the artifacts, and create the images. Next step here is when we promote the release, we use the kpromo tool to promote the images. Then we also build the Debian and RPM packages, but this step requires a Googler to finish and to move as well. So we have the Deb and RPM packages, which this is part of the effort. In one of the first few slides, when I talked about SIGs, there was a SIG-K8s infra that SIG was is migrating the infrastructure from Google owned infrastructure to CNCF owned infrastructure. So this is one example where we do have a dependency, since it is Google owned infrastructure, that we do need a Googler to do some things. Then we have the official announcement for the release. We announce it on various email lists as well, and we do a code thaw, meaning that the pull requests that are open for the Kubernetes repository can now merge. But part of the release, it's not actually finished yet, or the recycle isn't finished yet until the documentation is actually updated. So part of that with the Kubernetes.io website, which runs on Netlify, we have to add a Netlify site for it, for the update for the current version of the Kubernetes documentation. Then we merge in the integration branch for the Kubernetes/website repository with the main branch of the Kubernetes/website repository. Then we do some git tags. So we tag the last commit of the previous release. Then we tag the first commit of the new release. Then we publish the release blog. The publication of the release blog actually notes or marks the end of the release cycle. But of course, there's some post-release cycle activities. We also thought the Kubernetes/website repository as well, and we are part of the announcement that the release lead makes that the release is officially out. That pretty much highlights and summarizes releasing Kubernetes and how we have, before we actually talk about releasing Kubernetes, we have to talk about who owns the code and who owns the different parts of the Kubernetes project, and how enhancements or features are proposed and tracked. Then we talked about the release cycle and how those enhancements and the tracking is used in the release cycle as well. And then we briefly went through the release cycle itself and release day activities. So I want to thank you very much for your time. I hope you guys enjoyed this talk and clarified things on how a project like Kubernetes is released. Thank you very much.